Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about data breaches and secure supply chain with Steve Orrin, CTO of Intel Federal.
So we could talk about data breaches, but I want to talk about one other thing in supply chain that I think that didn't get the same noise. So everyone was talking about supply chain, whether it be SolarWinds and some of the others, because someone hacked in and was able to change the build process or affect the code. And there's some great examples of that have happened. But there's some other subtle changes or subtle supply chain attacks that haven't been as well advertised, but are equally problematic. And I think the one I would pick on is maybe the Great Suspender example. So there was a Chrome extension that was used by about 2 million people. It was basically an optimization tool for making sure that memory was being used correctly in Chrome applications. It was an open source tool, a tool that was developed by a group, and the founders that built that sort of open source tool sold their company. They were bought by an organization that they didn't do a lot of due diligence. They were offered, $5 million, $10 million, whatever it was.
That's all the due diligence they wanted, right?
And 5-person team, it gets offered a couple $1 million. You take the bill. That group that bought them was an organized crime organization, and so they turned that well-used tool into a supplier of malware and spyware. And so it was a legitimate product that the next day was illegitimate, but there was no attack in the sense that they didn't hack into that company. They just bought the company and then had the rights to do with what they wanted with the code. That change of ownership is another kind of supply chain that doesn't get the same credence or the same level as, someone hacked in and changed our code. Because the problem with that model is the code, the product that was delivered, even though it had malware, that was what the owner of that product intended. So no amount of signatures or hashing or any other security protocol would have fixed that problem. Now you need to start to vet who your suppliers are. And that's one of the things that if you look at the guts of the EO that was published, the executive order around software supply chain, buried in there is a notion of understanding the control or the provenance of the organizations and the third parties that support them, so that you're dealing with legitimate companies.
Does that make it much more difficult for open source then? Because open source, you don't really know who's contributed. You kind of do, but not really.
Yeah, and I think so there's a blessing and a curse with open source, or actually two blessings, 2 curses, 1 blessing. The blessing is it's open source, so you have access to the source. You can go review it all you want. Here's the curse. No one has the time and energy or expertise to thoroughly vet every piece of open source code that they're using. It's a heavy lift and a heavy ask. And as we've seen, because of that, malware, vulnerable code, even unintentional vulnerable code can be introduced, and if it's not caught by the community, it often doesn't get caught for a long time. And again, you think about the community, you think, the community will catch this. Well, the community is people who are interested in building a memory allocation widget. They're not security professionals. Are they going to build the best memory and most secure memory allocation widget? No. And as we saw, there was a really terrible example where some committers to one of the Linux kernels introduced vulnerabilities on purpose. It was a research project without telling anyone, and that code got implemented into the main line.
Was that the University of Minnesota?
Yeah, I wasn't going to call them out, but you can.
I'm calling them out.
Yeah, they were caught red-handed, and they claimed that it was a research project. Great, but they did something terrible. And the fact is, but it highlights that anyone could do that. And again, think about how many millions of lines of code are in a single, kernel or kernel patch, or how many hundreds of thousands of lines of code are in a given open source project. No one has the time to go and vet all of that code.
They don't. So here's a question I have for you. Do you see a trend being trusted open source where the people contributing come from a trusted organization, or come from that somehow trust could be built in the open source community with contributors?
I think that's a lofty goal. I doubt that would actually ever happen. But I do think what you'll find is there'll be 2 things that could happen. One is you could start to see, who are the good code, like a rating system. Not necessarily that you're bad, but there may be certain code contributors that
there most definitely are better programmers than others, right?
yeah,
I mean,
or ones that after their code has been run through a source code analysis tool have consistently come with less vulnerabilities or less bugs. That kind of rating system could be put in place, but I think what you'll find though is mostly it's going to be third-party vendors. Trying to think, SNCC is one, there are a couple others that will actually do the scanning of source code repositories and say, here's a trusted object, here's, this one is not bad, it's just not trusted yet. And so I think you'll see this cottage industry, and there's already some well-established startups in the space of verifying open source products.
Well, I'm already seeing it. I do a lot of development, as my my audience knows. I do a lot of development in JavaScript, right? I already know that they run security scans on my code with NPM and GitHub. They're running security vulnerability scans all the time now on my open source that I contribute and that other people contribute as well. So are those sufficient enough?
It's a control. Think of again. It's not security isn't all or nothing.
Oh, gotcha.
All right. So yes, it's good that you're doing that because you're implementing a security control. You're raising the bar, but that alone isn't enough. But not doing it is also not good. And so you want to combine that with other things. You want to, even when you're taking in third-party code that you've done a scan on, it doesn't mean you just let it run roughshod across your organization. You put additional controls, you monitor, that's one of the things you'll see in the EO and in other pronouncements, continuous monitoring, continuous assessment, not we're going to scan our stuff once a year and hope for the best.
Right, yeah. That happened with SolarWinds, frankly, right?
Exactly.
We trust them. They came in. They didn't know they had malware in their software for a year and a half or however long it was.
Exactly.
Gotcha. Okay.
So
let's
talk
data breach.
Let's talk data breach. Data breach continues to be a problem. The number I saw for 2020 was something like $7 trillion, if I've got my numbers right. Some ridiculous number. I can look it up in a minute, but we're seeing data breaches continue to be a problem and a large scale, and whether that be examples like McDonald's most recently, where customer and partner data and internal data was compromised, to the ones that are sort of international in scale, we are seeing this continue to be a problem. And so the challenge here is, what do we do about it? Well, number one, we need better security tools on our data and our infrastructure to protect us from the attack that led to the data breach. But the other is, this is where having encryption in place so that your data, even when accessed, is encrypted. And the idea is around default deny, so that once you get through the front door, you're not into an open, as they say, the eggshell approach. You want hard-boiled eggs. Sorry, yes, 1.8 trillion is the dollar of the data breaches, and 7.8 billion data records is what the current numbers for 2020 are. So yeah, I got the numbers transferred. So $1.8 trillion in value that was extracted across 7.8 billion records.
That's a very lucrative business right there.
Exactly. And that's just in the data breach side of it, not denial of service or other aspects of it.
So, you said the first line of defense, encryption, right?
Yeah. Encrypt your data inside the organization, not just what gets exposed to the cloud, not just what you send externally, but keep your data on the data that traverses your network, the data that's at rest, encrypt it. Furthermore,
so isn't encryption expensive though?
You'd think, and yes, encryption has a cost, but on modern hardware, there's built-in acceleration that obviates that penalty. So now you can turn encryption on everywhere across your organization without that performance impact, because your hardware has built-in acceleration by design for free when you buy the hardware. And 90% of the software ecosystem of commercial software and much of the open source by design and by default will take advantage of it.
Got it.
So no one should be able to say, oh, you turn on encryption because it's too expensive. That excuse is long gone.
Okay, that's good, because I use that excuse. So I can't use that anymore, is what you're saying. Okay.
And not on modern infrastructure.
Got it. That makes sense.
Then there's the other part is enclaving. So what I mean by enclave is segmentation. one of the challenges we see in a lot of corporate environments is that once you get in the door, it's free reign. Everything's connected to everything. There's been a push lately to take dev and move it into its own network. And I think that's a start, but that's the tip of the iceberg. We should have network segmentation across the organization so that you, just like you do in your OT system. So if you look at a good OT environment, you've segmented control from monitoring, from telemetry. We should be doing that across our corporate enterprise as well, so that different business units, different sub-processes are network segmented. Now, that doesn't mean they're not connected. You can still have transverse, but it's against a set of rules. And that will help limit the impact, so that if your help desk is the one that got attacked, your HR systems aren't necessarily compromised at the same time.
Gotcha. So micro-segmentation, that was the word of 5 years ago. It's real. It needs to happen. There are some great tools out there that do that, like the container ecosystems do this very well, right? Where I'm deploying an application, it's sitting on its own network with its own firewall. No one else can come in except through that firewall. There's monitoring on the firewall. And the cool thing about that is that happens when I just say deploy with Docker Swarm or Kubernetes. So using those tools can make a big difference, it sounds like.
Absolutely. Again, another control to help make the impact of the attack that led to the data breach that much less. Again, the other thing is implementing proper authentication credentials. The time is nigh. We need multi-factor authentication. We also need entity authentication. So one of the things that people think is, oh, if I get all my users to authenticate, I'm good. But there's a lot of automated tools, automated processes, entities that have elevated privileges that have credentials that aren't getting properly authenticated. So we need to have not just human authentication, but entity authentication to be enforced and secured and not given global power and root access across all things.
Well, and so most of those are build processes that have root access over everything. So
exactly. So we need to have better controls across all access questions. This is why, again, and I used to be a naysayer of the early stages of Zero Trust. I've bought into it now because we are getting real. Zero Trust has finally matured to the point where we can actually implement it. Some of those key tenets around default deny and trust no one are super important. And the technology has caught up to actually implement those kind of policies and procedures. So we're there now. So we should start implementing. We should start deploying those kinds of concepts. Now, if you go into go ahead.
As a software developer, every time that you say access denied, all that stuff, the first thing I think of, that's going to slow me down on development. Is that still true? Because it has been in the past. Every time I need to download a new package from a vendor, I have to open up the firewall. I've got to go through this whole process. Is there trade-offs there that we're still dealing with? Or have things gotten better around that?
I think there's a couple ways to come at it. So a lot of the default deny and the controlled access really comes down to how you've implemented your infrastructure. So forget about you as a developer for a second. Okay. If you are a developer and you have proper credentials and proper access, you should be able to access the things you need to when you request them. Keyword there, when you request them. Not having a credential, right? Not having a credential that just gives you access to everything all the time. And so the idea of a zero trust is, it's not that I don't trust Darren when you've properly authenticated and are doing a request for something that is proper for that moment. It's the credential that I could steal from Darren doesn't give me blanket access.
Gotcha.
And that's the thing. So you should be able to download the patch, again, knowing you've done the right vetting on that patch. You should be able to access the resources. Your program should be able to do the things they need to do, but they need to be able to do it in such a way where they present their credentials and their reason, or at the time a policy decision is made, yes, give this thing access for the period of time. So here's a great example. Give Darren access to do that function right now. And then when he's done that auction, drop the access. You lose the privilege because you don't need it anymore. You did your thing. And the next time you come in and you want to do it again, we can reevaluate. That's the key. That's some of the key tips that's lost in a lot. And that's one of the things why we needed Zero Trust to mature, because everyone thought, well, I'm just going to throw this idea and it's going to magically make things happen. No. But if we have those policy enforcement points and we have the policy controls, we can then start to implement this granular policy that takes a look at what you're doing at a given time, give you the rights you need for that moment, and then take them away. That's the real power here, because if you think about the way malware gets in, once it gets in and starts laterally moving, it's taking advantage of those persistent credentials and authorizations that persist across organizations.
So
we're taking that away.
Yeah, having the timed out credentials or time-based credentials sounds like that's a very important aspect.
Absolutely, yes.
Got it. Hey, well, Steve, this has been a wonder. It's gone by so quickly. We most definitely are going to have you back on the show. Thanks again for coming on. This has been wonderful.
Thank you, Darren. It's been a pleasure to be here again. I look forward to our next conversation. And I hope that as people start to listen to this and think about security differently, please feel free to reach out. I'm on LinkedIn /SORRIN/Soren. I'd be happy to help. This is an important topic for all of us. We all have to get this right.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and do something wonderful.